calculation using Excel. So everything, all the what we call the calculation for your example, I will show you using Excel how to solve them. Okay, so I'm not going to repeat again what we have covered for the concept of simple linear regression. Okay, so basically we have gone through 5.1 last week, describing in terms of concept, and today we are going to complete until 5.3 and maybe some initial concept of 5.4. Okay, so that will be the things that will be covered tonight. Okay, let's move to the material. So hopefully what you can learn from this chapter outline as well as the learning objective are the what we call the ability or your skill that we hope you can have that particular skill at the end of the coverage of each chapter. Okay, so this will guide you on what should you understand one by one in particular of what we have discussed in chapter 5. Okay, so don't disregard this particular thing because this is important for you. Now, last time I have discussed with you what is quantitative variable that involved in SLR. So when I say as a quantitative variable, as I mentioned just now, some of the students gave me one of the variable is not in quantitative form. When I say quantitative form, means that this y will be numerical. Okay, numerical value. This x also numerical value. Okay, and you know that the concept of simple linear regression, these two variables are related. We are not talking about effect. Effect is covered in chapter ANOVA. We are talking about effect when we are discussing about ANOVA. But when we are talking about SLR, we are talking about relationship. Okay, how does this text related to your one? How does the relationship looks like? Okay, so both of them should be numerical, and we know that y is depending on x, means that whenever y change, the change is in y is because of x. Okay, means that simply say whenever x change, y will change. Okay, so that's how the y and x are related. Okay, so last time I have discussed how we can name our y variable and x variable, dependent variable, response variable, outcome variable. So everything I think I have discussed about that last time. Now, what kind of relationship that we are talking about between these two variables? Okay, so in order for us to portray or to show what kind of relationship between our x and y, we are going to use our um, graph x and y. So usually our x will be in this particular horizontal, and our y will be in the vertical. So this will be the independent, and this will be the dependent. So you can see most of the time x will be at the horizontal. So make sure you put it accordingly. So this one will be the dependent. Now, there will be two kind of relationship between x and y. One of it will be, okay, for example, you have working experience and salary. Okay, so which one is depending on which? Ask yourself. Is working experience depending on salary or salary depending on working experience? Logically, the higher the salary, the higher the working experience. So, is it correct? The higher the salary? No. The higher the working experience, the higher the salary. Am I putting it differently? Why? Yeah, as worker salary. Yes, worker salary increases. So this is your X and this is your Y. Okay. As working experience increases, salary also increases. So in this case, you can imagine as x increases, okay, means that you are the movement is towards the outward, and then when y is increases, so it would be in terms of movement. So when you have this kind of relationship, you know it will be this kind of linear relationship between the working experience and salary. Okay, when you are talking about age and physical strength, okay, age and physical strength, okay. So in this case, your physical strength is your y, as you are increasing in terms of the physical strength, so it means that you are moving upward, and then in this case, your x is moving downward towards 0. So in this case, we are going to have this particular relationship. The higher the value of the higher the physical strength, the younger the person is. Okay, the lower the physical strength, the older the person is. So in this case, you have these two particular relationship. Now we are going to discuss further what kind of relationship we have for this particular case. Now, what if there is no relationship between x and y? For example, you are talking about age and shoe size. Okay, there would be no specific reason or there would be no specific way we can tell the older the people, the larger the shoe size. Because the shoe size is depending on height or maybe on the weight of a person. So in this case, we cannot really tell. Okay, when we cannot really tell, when there will be no relationship between your age, for example, and your shoe size, okay, most probably we cannot tell. It could be the younger the person, the larger the shoe size. Okay, it can also be the older the person. Okay, it will be moderate shoe size. Okay, or for example, maybe this way or this. So there will be places where you can see the between the two variables. Okay, the the relationship will be like somewhat the axis. It will be horizontal. Okay, so when you have a linear line, for example, as this one, you can see there will be no relationship between the two. Okay, because you cannot really tell unless you have obviously your points is uh, forming like this particular uh, data. So your data will be a hint for your relationship between the variables that you have. Okay, so there will be three kind of relationship. Now let's look at our example. Look at your textbook on page 167, example 5.1. Okay, describing the relationship between the two variables. So there will be three ways or three tools on how we can use to display the linear relationship between x and y. The first one is what we call scatter plot. The second one is sample correlation coefficient. And the third one is regression equation. Okay, so we are going to see one by one. Okay, let's see, we have our example 5.1, our physics score and mathematics score. And from this particular data, okay, so given in your textbook, there will be only 7. Okay, 1, 2, 3, 4, 5, 6, 7. So you have until 93 and 90. Okay, so this will be your data in example 5.1. Now let us see how we can use one by one to show or to describe and quantify the linear relationship between our x and y. Now what is scatter plot? Okay, a scatter plot is a graph of ordered pair. Okay, when we say ordered pair, means that we move from the smallest to largest data. Okay, so it is graphical way to determine if there exists linear relationship between y, your response variable, and x, your explanatory variable. Okay, so this is an example of your scatter plot. This is your independent variable, this is your dependent variable, and your data from your given table will be plotted in your scatter plot. So we move from the smallest data value. So in this case, coincidentally, it will be your first data value, 60 and 65, and you are going to finish until your end data. So for example, you are talking about 65 and 60. Okay, so for example, this could be your first data point. Okay, we are going to see this afterwards. Now, let's move to our example 1. Okay, 7 randomly selected students took a mathematics test before they started their 3-week class. Table shows the mathematics score and their corresponding physics test score. Construct and interpret the scatter plot for the following data set. Now, I wanted to show you how you can use your Excel to help you out with your scatter plot. Now, let's say you have your data here. Yeah, I have already downloaded earlier your data. Okay, but now I would like to comment the way you key in your data in your Excel, because you're going to use your Excel for your project 2. So what I would advise you to do would be, do not put your first column with your Y and then followed by your X, because why? If you plot this according to your Excel, you are going to have this. Okay, so you are going to have your Y somewhere over here. Okay, I'm trying to get my pen. Okay. Now, if you have this, what happens is that if you directly use your data here, this will be your
Doktor,
yes. You tak nampak ke?
we can't see your screen.
Okay, sorry. I forgot. I shared the screen just now. I should stop sharing. Thank you for letting me know. Stop sharing. I think the best would be share. Share. Hopefully, whenever I change the screen, you can see. Can you see the Excel? Can you see the Excel? Okay. Okay, thank you. Now, when what I mentioned just now, do not put your Y in your first column followed by your X. So what happens if you use your Excel, this become your Y and this become your X. Okay, now we don't want this. Okay, so I would advise you to put, instead of Y and X, locate your X first, okay, and then locate your Y. Okay, so how do we do our, what we call our scatter plot? Okay, highlight your data, okay, go to data here, and then go to data analysis. Oh, sorry. In here, you insert. That would be for analysis, okay? Highlight your data, go to insert, and then choose scatter plot. Okay? And coincidentally, you are going to be given this particular graph, unprocessed graph. So you have to do something with your graph. So I would like to have my graph as good as nicely as this one. Okay? Okay, so if you look at this particular graph, you can see you have physics score, you have mathematics score, and your x-axis and y-axis are nicely being portray in terms of the range of value for your x-axis and y-axis. If you do not change, you will have kind of this particular graph. So what you can do is that you go to plus sign, okay, go to axis, okay, and then click more option. Okay, when you have option, make sure you have axis option here, and then you are being given the option for your bounds. Okay, so axis option, so I would like to have for my x, so I make sure that this is for my x, so I would like to start with 6 just one I start with 60, right? So I would like to start with 60, or maybe you can put 55, for example. Okay, 55, let's say I put 55, and then since the largest data is somewhere below 100, so I make it 100 maximum. Okay, and then you see your axis change for 55 until 100. Now you wanted to change for y. Okay, go for y, go for vertical axis, and then change the minimum value to, for example, 55 as well, and then maximum 100. Okay, so you can stop, and then what next? You don't want the title. If let's say you don't want the title, if for your project you need to put the titles, and then put the title, but you can add your axis for your axis name using add chart element here. Okay, so for x-axis, okay, put mathematics score. Okay, and then once you're done, you can click your graph, and then go again to your add chart element, go to y-axis, and then you can change the name into physics score. Okay, so that's how you can do your scatter plot. What is the difference between this scatter plot and the original scatter plot? Sometimes when you are using this particular scatter plot, it will not really tell you in terms of the line itself, because since you are dealing with less number of data points, so it will be okay. But if you are dealing with large number of data points, okay, it will be good if you go for the correct dimension, so that you can see clearly how your transition from point to point is available for your from your data. Because why? Later on we are going to have our line data, or line for your data here. Okay, so that would be first for your scatter plot. Do you have any question, class, for your scatter plot? So done for scatter plot. So let's move to our second example. So can you see my note 10, class?
Can do it.
Okay, now I haven't finished interpreting the plot just now. Okay, if you can see, when you have your plot somewhat like this one, I have copied for you. Okay, so this is your plot for your mathematics score and physics score. So when you are being asked about the interpretation, so the way you construct done, now you need to interpret the scatter plot. So now in terms of interpreting, you need to mention about the linear relationship. Okay, linear relationship, whether they are positive or they are negative. We know when they are positive, they look like this, and if they are negative, they look like this one. Okay, so what can you tell from here? You can see as x increases, okay, y also increases. So in this case, we can say, so according to your look at your textbook, just to make sure everything is correct. Okay, so we could say that there is a positive linear relationship since the pattern ordered pair looks like a straight line. Okay, if that would be your long answer. Okay, it seems to be there is linear relationship, okay, between math score and physics score, okay, since the scatter plot, if you wanted to put it in a simple way, since the scatter plot form a straight line. Okay, so that would be your interpretation. Now, let's move to the second example. So move to your next page, that will be on page 168. You have your second example, example 5.2. So sorry for the spelling mistake. Okay, so a researcher wishes to see if there is a relationship between age, that is X, and net wealth, your Y, of the wealthiest people in Asia. The data for a specific year are shown below. Construct and interpret the scatter plot for the given data. You are given this data. So how we can plot this? Okay, so I think I don't need to show you how you can you can use your Excel to do the scatter plot. Okay, but somehow I don't have my answer here, so I think I need to show you the Excel. Now let's see if we move to second example. Now in this case, when I do the scatter plot, okay, I have this particular scatter plot. Okay, so I have my age at the x-axis, and I have my net worth in billion in y-axis, and you can see your data are scattered around without what we call a clear direction, whether they are in positive way, okay, whether they are in positive way or in negative way. We cannot really tell. Okay, so in this case, how would you comment? Okay, so how would you comment? So in this case, we would say, okay, the scatter plot, okay, the scatter plot does not show a clear linear pattern, or you can say linear pattern or relationship between age and network. Okay, so okay, so the note in your textbook, okay, as age increases, okay, as age increases, age cannot confirm a higher network. Okay, because we cannot really tell. Because as a person is at the age of, let's say, 64, the net worth can be 3.5 billion. The same goes to at the age of 56, for example, the net worth is around 2.1 billion. So there will be no specific range. So in fact, you have 86 to data with 4 point, for example, 4.7 billion. So there will be no specific pattern of as X increases, Y increases, or as X increases, Y decreases. You cannot really tell. Okay, so if you don't have any question, I'll proceed to the next example. Now, the next tool would be finish with this scatter plot. Now, have in mind that scatter plot only shows the direction or the pattern of your linear relationship, whether they are positive or they are negative. So your scatter plot will be limited in terms of telling you further information of your data in hand. So why do we need scatter plot class? So sometimes you will be asked this, why do you need scatter plot? Somehow because you can use your whatever equation later to see how does your relationship between y and x. But in the first place, why scatter plot need to be done first? Because it will give you an idea how does your x and y in terms of relationship using the scatter plot. So that would be the function of scatter plot. Now, in addition to scatter plot, you can also have your sample linear correlation coefficient, or sometimes we use R, okay, to show to represent the linear correlation coefficient. Now, what is linear correlation coefficient? Okay, correlation coefficient is a numerical measure. So we are talking about numerical measure computed to determine the strength. So you are talking about strength, and the second one is the direction. Okay, direction means that you are talking about positive or negative. So this one is being given by your scatter plot just now. So your scatter plot cannot tell in terms of strength, but it only shows you the direction of the relationship. So why do we need R? Because R can tell you the strength of the relationship and the direction of the relationship between X and Y. So how does R computed? Okay, so if you are in normal semester, you are going to use this formula to calculate your R manually. But since you are going to use your Excel, so I think I need to show you how this R is being calculated manually. Okay, so now R is computed using sum of square of the X and Y divided by the square root of sum of square X multiplied with sum of square Y. What is sum of square X, Y, 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 and X, X means? Okay, those who just came in, someone please share with me your friend who just came in the link for your attendance. Okay, now the way we calculate our sum of square of X, Y is based on the sum of square or the variation between X and Y. So if you are talking about X and Y, we will do the variation between X and Y. This is variation between the X itself. This is the variation between the Y itself. So the way we calculate them, okay, so for X, Y, we will multiply the data value. Okay, so we are going to multiply the data value means that we are going to multiply our X and Y, then multiply X squared, then multiply Y squared. So we find the summation of X, summation of Y, summation of XY, summation of X squared, summation of Y squared. And we are going to use this value to find your answer. Okay, so we need to find this first. SXY, so this is the way we find the value. SYY, we use the square and the Y summation of Y squared divided by X, also repeating the same process of Y. Okay, so this is how we calculate our SXY, XXX, and SYY. And by using those three values, we find our R. Now, what kind of R in terms of number? Okay, so R can take place between -1 until +1. Means that R is between -1 until +1. Okay, so that will be the largest and minimum, the smallest value of your R. So R, if you are talking about -1 of your R value, you are talking about strong relationship. If you are talking about +1, you are talking about strong positive relationship. So they are still this one is positive, this one is negative. Yeah, correct. Okay, so if your R is approaching +1, okay, you are talking about strong relationship. If your R approaching -1, for example, negative 0.99, we are talking about strong negative relationship. Okay? Now, what if in the middle? What will be my middle value? 0 is my middle value. If your R is equal to 0, means that there is no relationship between X and okay, no relationship between X. What if my data, my R is equal to 0.5? You can say moderately strong relationship. Depend on your interpretation. But if you got positive one, it will be strong positive relationship. If you have negative one, it will be strong negative relationship. It will be if it is approaching 0, weak relationship. Okay. So now, what can you portray from this particular positive and negative R? Okay, so there will be 6 examples of how your R can be portrayed using your scatter plot. So imagine class, this is your scatter plot. Now, if you have perfect 1, your R is equal to 1, means that very strong, perfect positive 1. Okay, what happens is that your scatter plot will be will form a straight line where all the dots will fall along the straight line. Okay, you can see that there will be no data that outside from the straight line. So this is what we call perfect. Means that your data will be located on the straight line. The same goes to your negative 1. Okay, for your R equal to negative 1, negative relationship, all your data point will be forming a very straight line. Okay, but what if the value of your R decreases? For example, we have R is equal to 0.85. If you have your straight line, your straight line could be like this. For example, this is your straight line. You can see few of your data is not or are not along the straight line. For example, this data, these two data, this data, all this data, is some of your data here. All these data are not on the straight line. So that's why your R will be. And as your R decreases a lot, approaching 0, you see that your data become larger in terms of error. So the distance between your data point to the line is what we call as error. All these are error. Okay, so these are all error. Okay, so the more error between the data point to the straight line, the less the R value. The same goes to the negative relationship. And when you are talking about R equal to 0, no specific line can be formed, okay, in your scatter plot. Or you can say it could be this way, maybe. Okay, class, do you have any questions so far for this particular part? Any question? Class?
No, sir.
Okay, no. Okay, thank you. Now, you have to remember there will be properties of your R. Okay, what are the properties? The closer R to 0, the weaker the relationship. As I mentioned just now. R has no unit. Okay, it's just a number. The value of R remain unchanged if your X and Y are interchanged. So be careful, class. Do not interchange your X and Y. Because why? If you plot your Y here, your X here, your plot could be, if you're talking about your X and Y just now, you're talking about this, for example, this relationship. Okay? Okay, so it will be dangerous for you if you choose wrongly what will be your Y and what will be your X. So please do not interchange. So if you if you do interchange, your R remain unchanged. Okay, so that would be the dangerous part. And the third one, R is sensitive to outlier. What is outlier? Outlier is what we call deviant data. Means that your data that is too far away from the other data set. So if you are talking about your data here, let's say this could be regarded as your outlier because they are too far away from the rest of your data point. The same goes to this one. For example, maybe these are your outlier. Okay, so your data that is too deviant from the rest of your data set. Now let us move to example 1.3 on page 169. Okay, now refer to example 5.1. So you are talking about mathematics score and physics score. Calculate and interpret the sample correlation coefficient R. Okay, now you are using your Excel. How we can use Excel to find your R? So if you look back to your calculation manually, so you have your X, you have your Y, you will need to find your X squared, your Y squared, and XY multiplication. And then find your summation of each of your X squared, Y squared just now. And then you are going to put into your what we call formula to find your SXY, SXX, SYY. And then once you got your data, you are going to put into your calculation of. Now let us see how Excel do this. Very simple. Okay, so let's move to Excel. Example 5.3. Okay, now we have our data here. Okay, so first you can highlight your data or you can just go to your data here. To highlight your data or you don't highlight also can, go to data, go to data analysis. Can you see my Excel class? Class can. Okay, go to data analysis. Okay, thank you. Go to data analysis and find correlation. Okay, find correlation. You have here correlation. Click OK. You need to have your input data range. So go to input data range, click the arrow, and then specify your data. Then go back to your arrow, and then you have your data in terms of column, and you have your what we call your title here. So group by column. Then I have my label in the first row because I have my mathematics score and physics score. And then I want my output to be in the same sheet. Okay, go to arrow again. And then let's say we click somewhere here. Then go back to your data window and then click OK. Now you are going to have this. Okay, first, what can you observe? Okay, you have what we call a 2x2 table. Here, a 2x2 table which shows your X and Y, X and Y. So we are talking about correlation. Means that correlation is hubungan, relationship. Correlation between X and X, definitely it will give you 1. Because you're talking about the same exact variable. So that's why perfect relationship. But this is not the one that we need to focus on. The one that we need to focus on is Y by X. So we are talking about this particular value. Now our R is actually equal to 0.991. So here R is equal to 0.991, 3 decimal point. So if you look at your calculation manually, you can also have 0.991 from your manual calculation. Now we know that our R is approaching 1 and we know that it is strong. It's strong relationship between our X and 1. Okay, so the question just now asks about calculate and interpret the sample correlation coefficient. Okay, so I think I have my answer in my note. Okay, okay, so we have our R. Okay, so how can we comment on this particular value? Okay, so to answer the question, okay, calculate and interpret the sample correlation coefficient R. So in this case, okay, R indicates a strong positive linear relationship okay, between physics score and mathematics score. Okay, that's it. So finish with your R by using Excel. Any questions so far, class? Any question?
No, doctor.
Okay, with no question, let's move to the next question. That will be from example 5.2. We are talking about age and net wealth. Calculate and interpret the sample correlation coefficient. Let's say we do the same process as what we have done in example 5.3. Now, our table shows this. Okay, and we know that our R is given by 0.046, very small, near 0. Okay, so we know from the plot as well, we cannot really tell how does the relationship between the x and y. So what can we comment from here is that, okay, so since R is equal to 0.046, which is approaching 0, okay, thus it suggests that the age and net wealth, okay, has a very weak relationship. Okay, very weak relationship. Okay, so that would be your interpretation for your R equal to 0.046. Okay, so that will be example 5.4. And then, how would we know that our calculation is correct? Okay, since we are just using our R to help us out in terms of interpreting whether we have strong or weak relationship apart from your what we call direction. Okay, so if you see class here, your R is positive. So again, do not forget that you have positive relationship. Here also positive but very weak. So since it is very weak, we don't say about the positivity or the relationship between the age and platform. Okay, so next, hypothesis testing for significant linear correlation between X and Y. Very quick because this is supposed to be not be covered in your case, but I think I'll just go through because you may need it something later. Now, we have seen how we begin with our scatter plot. Okay, we begin with our scatter plot now to see the direction of our data X and Y. Then we move to our sample correlation coefficient of R. And R tells you the strength, okay, and the direction. Now, how do we know that this R is acceptable, is reliable? So we need to check. Okay, so then how to check? We do the hypothesis testing for whether there will be significant linear correlation between X and Y. So how do we perform our hypothesis testing for R? Now, when we are talking about hypothesis testing, remember class, when we are talking about hypothesis testing, again, we are talking about inference, making inference. Okay, and when we are talking about making inference, we know that we are talking about population. Okay, and then we are not going to use our data from our population, but we are going to focus on our sample to help us out in making the division for our population. So what happened class here? Okay, so for your population, the notation of your correlation is given by rho. Okay, okay, so your sample correlation is given by R. Now, from your sample data, okay, you are going to do some hypothesis testing. So that's why your null will be rho equal to 0. Your alternative will be rho not equal to 0. So what does equal to 0 and not equal to 0 means? So there will be no significant correlation between X and Y, and significant correlation between X and Y for none and alternative. Okay, so HA or H1 is the same. Okay, so they are telling the same thing. Alternative is stand for alternative. But we usually do use H1. Now, we need to test whether the rho will be equal to 0 or not equal to 0 based on our sample data. Now, let's say we perform our hypothesis testing, for example, 5.3 just now, okay, with regard to your mathematics score and physics score. Now, we have our data. So you need to perform the hypothesis test for the significance of linear correlation between physics score and mathematics score using alpha 0.05. Okay, so how do we do that? Now, look at the step by step. The same exact step involved in your hypothesis testing for sample correlation coefficient. So in this case, your first step will be note down your hypothesis statement. So your null would be rho equal to 0, or you can write there is no linear correlation between physics and math score. And alternative, there is a linear correlation between physics and mathematics score. Next, your critical value. Okay, so your critical value, since you are dealing with n equal to 7, so in this case, in simple linear regression, we are assuming our data are normal. So when they are normal, we are going to use, since the data is less than 30, then we are going to use our p-distribution. Okay, for the p-distribution, what happened is that your p alpha would be 0.05 divided by 2. Why? Because we are dealing with two-tail test. Two-tail test. Okay, so when two-tail test, we know that our p-distribution is almost the same as normal distribution. Okay, so you're going to have two rejection regions. Okay, and this is where your alpha over 2, and this is your alpha over 2. And this is p alpha over 2, and this p alpha over 2. And you have your parameter that will be n minus 1. Sorry, n minus 2. Okay, so that's why for your p critical value, you will have p alpha over 2 and n minus 2. So that will be p 0.025, and 7 minus 2 is equal to 1. Now, let's move to your p distribution. We have 5, degree of freedom is 5, and your alpha is 0.025. let's look our T distribution. Okay, we are talking about 0.025, so we are talking about this column, and we are talking about 5 degree of freedom, n minus 2. So we are talking about this particular value, 2.5706. So take that value, okay, and since we are dealing with two kilotons, so automatically your theta value of your T critical value will be plus minus 2.5706. Okay, so that will be your critical value. Once you have got your critical value, find your test statistic. That would be your calculated T. Now, in terms of your SLR, your calculated T or your T test is obtained by using this formula. You are going to use your R, and you are going to square the R, and you are going to use your sample size, your N. Okay, since for our math and physics for just now, our R is equal to 0.991. Okay, so put everything together into your formula. So you are going to have your test statistic equal to 16.55. Compared to your critical value. Now your critical value is between negative 2.5706 and positive 2.5706. Okay, sekejap makan ada kelas. Tak lagi makan tadi tu. Okay, okay, so once you have got, okay, your t-test statistic is 16.55, which is very far away in your rejection region. So let's say this is 16.55 in falls in the rejection region. That's why we have to make decision reject null hypothesis. Okay, when reject null hypothesis, okay, means that our statement of alternative is accepted. Okay, so in this case, what can you say? There is sufficient evidence to conclude that there is a significant linear correlation. Okay, linear correlation. Okay, linear correlation. I would like to make a correction here. Correlation. Okay, between physics score and mathematics score at alpha 0.05. So that's how you are going to use your R to check whether your R that you obtain from your sample data is actually acceptable or not to make inference for your population. Okay, class? Is it clear? Is it clear class? Okay, so means that from your sample data, you got your R, and then your R is 0.991. Then you go for hypothesis testing, and your hypothesis testing is testing for the correlation for your population. Okay, so remember class, so you are testing for your population statement, your parameter. Okay, parameter of the correlation coefficient of parameter means that population lah. Okay, so this is our sample correlation coefficient. Okay, so you are dealing with two different this is your statistic, this is your parameter. Okay, done with hypothesis testing. Now let's look at our exercise 5.1 because I need to show you because we are dealing with positive linear relationship, no relationship, for example 5.4. So I need to show you how does negative linear relationship looks like. So I guess example exercise 5.1 on page 173 would be best example, okay, for your negative linear relationship between x and y. So let's say we are dealing with this data, okay. A and N tenaga elektrik 9 berhad wants to determine the relationship between kilowatt hours use and the number of rooms in a budget hotel in Kangapolis. Okay, a random sample of 10 hotels yielded the following. So you have number of rooms and you have kilowatt hours in thousands. Now you have how many data? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have n equal to 10. Okay, now which one is dependent, which one is independent? Plus. Which one is dependent, which one is independent? Because you are not being given the mean of the x and y. How would you know? Okay, so please ask yourself, is kilowatt hours depending on number of rooms or number of rooms depending on kilowatt hours? So if you can see, okay, uh, we may say it could be the more room number, the more room are used, the less could be the kilowatt hours. We cannot say the more room, the more kilowatt hours. Is it correct? So most probably, most of the time, kilowatt hour will be depending on your number of rooms, right? Am I correct? So in this case, your dependent variable, okay, so your dependent variable would be your kilowatt hour and your independent variable will be the number of rooms. Okay, done with number one. By using Excel, sketch the scatter plot. Is there appeared to be any linear correlation between the variable? Now you're talking about scatter plot this time. Okay, so from the scatter plot, is there any linear correlation between number of room and kilowatt hours? Let's see how Excel gives us in terms of the scatter plot. Okay, now we have exercise 5.1. Okay, so number of room is your x, kilowatt hours is your y. Okay, do you want me to show how to plot the scatter plot class again, or directly explain from the scatter plot?
Show, Doctor.
Show, yeah. Okay. Now we have our data. Okay, highlight your data. Go to insert. Go to this particular graph. You can see insert scatter. So click insert scatter and then choose this one. Okay, so you have this. Okay, let's say I put it. Okay, I want to have this nice axis of x and y, where I can see clearly how does the relationship between the number of room and kilowatt hours. So I would like to change the setting. Go to the plus sign. Go to axis, and then go to the arrow here. Click the arrow, and then choose more option. So you can see here, if you click here, you can have the option that you have. Let's say we do the horizontal axis first. That will be your x. And I wanted to be begin with I think the smallest is, let's say 15. Put it 10. Okay, let's say I put it 10. And then the largest would be 30. So let's say I put it 35, then acceptable. So I go to the vertical axis. I do not choose the major grid line. I just choose the axis, and then change to the smallest value for your y is 17. Let's say I choose 15. Okay, 15. And then the largest for y is 28. So let's say I choose 30. Okay. Then click here. Then you have this. So I don't want the title. So for your project, you can put the title. So I wanted to put the axis of my graph. So go to add chart element. Go to X. And then let's say this is your number of room. and then click again. Once you got this particular appearance, go to add chart element again, and then go to Y, and then change to kilowatt hours in thousand. Okay, so you can put 1000. Once you're done, click the graph. Then you have this. But we can see that it could be positive, it could be negative. So if let's say you don't know clearly because the scatter plot does not really tell, okay, could be negative because we have data somewhat here. But if it is positive, like impossible because we begin with this particular data and it seems that this is too much away from your other data. So what can you do? Just go back to your data and then click your data. Panel is hiding my. Go to data, go to data analysis, go to correlation, click OK. And then highlight the value. Okay. Then go back to your group by column, label in the first row, and then I want to put the plot here. Okay. Click OK. Okay. Once you get this, okay, so you can see that your correlation is negative. So you know that, okay, it appears that the correlation is in negative way. Okay, very small. Okay, very small, negative. So means that your plot is giving you somewhat this. Okay, very not stiff one, almost horizontal because of the scattered data. Maybe this way. Okay, I think it's too much because almost negative. So it could be this way. Okay, so you can say for your answer just now, okay, is there appear to be any linear correlation between the variable? What can you say to us? Okay, because your value just now is, okay, your number 2, your R is equal to negative 0.0126. Okay, so since because you are using your scatter plot, so you are not using your R. So class based on your scatter plot, based on the scatter plot, you can almost have answer as what you have in your each and that box. Okay, based on the scatter plot, okay, the you can say the scatter plot, based on the scatter plot, there is no obvious relationship, okay, between the number of rooms and kilowatt hours. Okay, no obvious relationship between the number of room and kilowatt hours. Okay, so if you can, if you wanted to say they are negative, negatively, there is a negative, weak negative relationship can also. Okay, but since the scatter plot does not really tell the direction of your what we call your scatter plot, okay, and the direction of the line, okay, so we can, I think the best answer would be this one. But if you assume, okay, let's say your answer, it seems that number of rooms and kilowatt hours has negative linear correlation. Okay, weak negative linear correlation. Weak negative linear correlation. Okay, but I would prefer to answer using this one. Okay, now compute and interpret the sample correlation coefficient. Now we have got our sample correlation coefficient. Okay, so our R is equal to 0.0125. So do not worry too much if your reason here is somewhat contradict. Okay, but in this case, this one is okay lah with the value here. But if you're answering this, okay, and your next answer is this one, okay, so in this case, what can you tell from your R is that, okay, the question is compute and interpret the sample correlation. Okay, so R value indicates negative linear relationship between indicate weak negative linear relationship between number of rooms and kilowatt hours. Okay, that's it. Now, your next question would be test whether there is a linear correlation between both variables using alpha 0.05. Let's see how we can do that. Now, we know that our first step would be statement of our hypothesis. Okay, no relationship and no correlation and exists correlation. And for alpha 0.05 and n equal to 10. So our critical value would be P alpha over 2 and the next parameter is n minus 2. So you get 10 minus 2 will be 8. Alpha divided by 2 is 0.025. So if you look at your P distribution, 0.058, 0.058. So you get, 0.0258. So you have 2.3062. Okay, so you get 2.3060. Since we are dealing with two-tailed test, 2 plus minus, don't forget. Okay, so we have got our critical value. Then our test statistic using our R and N. So you will get negative 0.037. So if you plot in terms of the decision, so you have negative 2.3060. You have positive 2.3060, and this is your rejection region, and your test statistic is negative 0.037, which is near to 1. So your test statistic is negative 0.037. So false in the non-rejection region, so fail to reject hypothesis, then we have insufficient evidence to conclude that there is a significant linear correlation, okay, between number of rooms and kilowatt hour. Okay, so that's how we do the hypothesis testing for the sample correlation coefficient and to make decision for our room. That would be our population correlation coefficient. Okay, class. Do you have any questions so far? Do you have any questions so far?
So far, no, Doctor.
Okay. So we have another 30 minutes. Okay, so let's see what we have in the next page. Now we have discussed about scatter plot. Of course, we have discussed about the concept plus terms. Okay, some of the terms. Second, we have discussed about scatter plot. Okay, the function of scatter plot to show you the direction of your relationship or correlation between x and y based on the scatter plot. Third, you are using your R, that will be sample correlation coefficient. Okay, and your sample correlation coefficient show the strength and the direction of your correlation between x and y. And number 4, hypothesis testing for our R, okay, for our sample correlation coefficient, R to make decision for your rho. Okay, so this is sample correlation coefficient, and this is your population correlation coefficient. Okay, so far that are the things that we have covered. Now, what else? We haven't talked about the model. Okay, so we don't know how does our equation of our straight line that we are talking about this or maybe this one. What how does the model for this particular line looks like? Okay, so the next part will be regression equation. Why we call it regression class? Because by using this particular line that we are going to form afterward, okay, we can do some prediction, okay, but your prediction will be between the line of your data that you have in hand. So this will be your what we call prediction of your y using your x. Okay? Can you do prediction somewhat here? No. Can you do prediction below the data point? No. Your prediction can always be done within your data point. Okay? Within the data point. Okay? So that's it. Now, what about this regression equation that you should do, class? Remember, class, again, we are talking about work population, okay? And then we are using our sample to make analysis, okay? Now, when we are talking about our sample, okay, our model for our regression equation is given by y hat is equal to beta naught hat plus beta 1 hat x. This is an estimated model. Okay? This is an estimated model. What is the real model then? The real model is based on your population data. That will be capital Y equal to beta naught plus beta 1 x plus epsilon. Okay, so this is your real model, real regression equation. But since we are dealing with our data, okay, based on our data, we are going to have our regression equation for our sample data. So that's why we are estimating our real model using sample data, and this is the thing that we are going to discuss a lot afterwards. Okay, so how do we estimate then? How? By using the population, we are estimating using the sample. Okay, the method that we are using is what we call least square method. Okay, so for that particular part, least square method, you can have that on the page of regression line. Okay, so you can have that on page 176. Okay, this one is on page 176 in specific. We discussed about this, how to find this particular equation and how does this equation looks like. For example, this is your scatter plot, then this is how your equation line looks like. Okay, so if we go back to our example that we say we discussed so far, our equation will be looks like this one. Within the line of your maximum and your, okay, so this one it should be from here. So this is your regression. So if I can write it, this is y hat plus beta naught hat plus beta 1 hat x. But we don't know yet what is beta naught, beta 1, just in terms of concept. So what is my equation line here? Okay, so we have a positive, very weak. Okay, so this is my y hat equal to beta naught hat plus beta 1 hat x. What about my here? This one? This will be my line looks like. Okay. Okay, so that's how we do the regression. We do the plot of our regression line and how we find our equation. But as I mentioned just now, okay, so this is your area. Okay, and then what is your beta naught? Beta naught is your intersection of your x intersection of in y. Okay, so this is your intersection. Intercept at 1. What is beta 1? Beta 1 is your slope. Okay, if you can see, if you have positive, then it would be positively related. If you have negative, for example, this way, your beta y naught y hat will be beta naught hat negative minus beta 1 hat x. So it shows here. Okay, that would be the difference between positive and negative slope. Okay, so this negative slope is also guided by your R. If your R negative, then it would also reflect negative correlation between X. Now, what is my regression equation? So I think I need to stop until this slide. Okay, so I have 1, 2, 3, 4, 5. Very quick, because you are not going to do it manually. Since in your Excel will going to help you in terms of calculating what is beta 1 hat, what is beta naught hat, and you don't have to worry about this one just now. We have mentioned this earlier on. Okay, so your regression equation will be given by your Excel. Okay, but the way the least square method is being used in terms of the calculation, you can read it on your textbook. Now, let's say we are talking about this equation line. Okay, now go back to our example 5.7 using example 5.1 data set. Okay, so if you look at equation or example 5.7, so you can refer to page 5.7, sorry, page 177. Okay, find the regression equation for data in example 5.1 and sketch the regression line. Okay, regression equation, one thing, and sketch the regression line on the scatter plot of ordered pair, interpret the slope. Now, let us look how we can do that using Excel. Okay, I'm not sure how many of you are still in my class. Okay, so let's go to example 5.7. Okay, we have our data. Okay, I'm going to show you how you can plot your equation and your line. Okay. Now go to your what we call. I'm going to show you from the beginning. Okay. So I have my data. Go to insert. Go to scatter plot. Okay. Bring back somewhere so that easy for you to. Okay. Let's say I enlarge the plot. Okay, so let's say I change. Okay, so if let's say if I don't change, okay, just do it as use it as it is even uh, in your Excel. So let's say just to put the so this is maths. Okay, and then we have our physics. Okay, so we have physics. Now, how do I add the equation line and the regression equation? So go to plus, go to trend line, okay, go to more options. Okay, you can put, okay, you can have the line has been done for you. Go to your bottom part, still in the trend line option. Uh, Display equation on chart. Okay, done. So your graph will not be so nice. So you can adjust the what we call the, the axis of x and y. So if let's say you have adjusted your x axis and y axis, so you have this particular graph. Okay, so if let's say the font is too small, you can adjust the font by clicking the font size here. Let's say I want make it 16. Okay, so this is my equation for my uh, physics score with my mathematics score. And then this is my line. So if let's say the line also is not clear, you can change the format. Okay, you can change the format. Let's say you don't want to have the dash, you want to have the solid line. Okay, and then you want to change the line, so you can also change the color as well as the thickness of your line. And you can see in class, your trend line or your equation line is beginning from the what we call the minimum point, okay, to the maximum point. Okay, so not beyond, not before, that after. But you, if you can go and expect the intercept, so you are going to have your interception somewhere uh, greater than 55. Let's say maybe 56, maybe 54. Okay, so this is your data. So this is your data one. Okay, because you have x here. This is your data not. Okay, data not here. So this is your interception of your one. Okay, so you can see your beta one is having a positive value. Okay, so it shows that your R also will be positive value. Okay, so let's go back to our note just now. Okay, so in this case, what are the questions just now? Find the regression. The question just now, sketch, okay, the regression line on the scatter plot and find the regression equation and interpret the slope. Okay, now what can we say about the slope? If I rearrange in terms of writing, because I like to have the interception at the beginning, so I have my y hat is equal to negative 2.5294 plus 0.9944 x. Okay, which one is my slope? This is my slope. okay, which is my beta 1. What does my slope means? Okay, you need to interpret the slope. Okay, what does the slope mean? If you look at your textbook, okay, page 100 and okay, so if you can see clear and what we call specific method on how to use your manual calculation and manual drawing to find your equation and your line. You can find it on page 177. Okay, but since you're using your Excel, so you need to know how to interpret your beta value. Now, okay, so you need to interpret your beta 1, which is equal to 0.9944. What does 0.9944 means to this particular equation now? We are talking about mathematics 4 and physics 4. Okay, and now we are talking about this one is your maths score. Okay, and this is your predicted. Why predicted? We have this hat. Okay, because we are talking about this line. Okay, this line is represented by this particular one. Of course, in your Excel, y hat is not written, but we know that this is referring to your y hat. Okay, so this is your predicted y. So when we say predicted y, the whole point here is referring to all the predicted value. Why? Because using my x here, for example, this is my 71, I can find my predicted y value. That would be this value. So in this case, I would say this could be 68. Okay, what would be my prediction of 70? If she got 71 in mathematics 4, what would be the predicted physics 4? It would be 68. So that's how we use the predicted line. But how do we expect in terms of change in x? So class, since the coefficient of your x is given by beta 1 hat, given by 0.9944, okay, so what does it tell you? Okay, an increase of 1 unit or an increase of 1 unit in x, okay, an increase of 1 unit in x, okay, would okay, increase in average 0.9944 unit in 1 or in physics 4. Okay, means that if you got 1 unit, additional 1 unit for your math score, it will affect an increase of 0.994 increase in physics score. Okay, means that 1 unit, if let's say your x is equal to 1, okay, so your y hat is equal to negative 2.5294 plus 0.9944 multiplied with 1. So you will get what here, class? Okay, so if you calculate, okay, you will get the value. An increase of 1 unit in x will increase a unit 0.9944 in 1 or physics 4. So that's how you interpret your slope based on your regression equation. Okay, so now class for that 12, okay, So you have this. I don't think we need to discuss because that, well, the correlation is very weak, so it will not be